Welcome. In this video, we'll explain how Mass Effect's simulation-based approach to tactile feedback differs from traditional effect-based systems, and how that can improve both the driving experience and the overall setup process. Before we begin, this isn't an installation or setup guide. If you're looking for help getting started, our quick start guide is linked in the description below. If you're new to tactile feedback, or even if you've been using it for a while, it can be difficult to understand how all the pieces fit together. You'll hear people talk about effects, frequencies, transducers, profiles, tuning, isolation, sim hub, and countless hardware combinations. All of those things matter, but together they can make tactile seem much more complicated than it really is. We'll start by looking at how traditional trigger-based tactile systems work, then we'll explain how Mass Effects takes a fundamentally different approach through continuous simulation. Finally, we'll see how that same philosophy simplifies the overall user experience, reducing setup complexity so you can spend less time tuning and more time driving. I've been exactly where many new users start. At first, the reaction is usually, wow, this is really cool, but after a while, something starts to feel off. You know there's more potential, but it's difficult to explain exactly what's missing. So let's start by understanding how traditional trigger-based tactile systems work. At its core, traditional tactile begins with telemetry from the simulator. A simple example might be engine RPM. The tactile software monitors that telemetry, detects a change in RPM, and triggers a tactile effect. That effect is assigned a frequency or a frequency range. The signal may then be shaped using a gain, modulation, smoothing, noise, or delay before finally being sent to the tactile hardware. The basic process is straightforward. Telemetry comes in, an effect is generated, the signal is shaped, and the hardware responds. For many users, that works well. Traditional tactile is flexible, familiar, and capable of producing useful feedback. The challenge begins when you want the entire vehicle to feel believable. A real vehicle doesn't produce just one tactile sensation. Even something as simple as engine RPM may require multiple effects, a low, a mid, a high frequency, working together to create a believable engine. Now add gear shifts, road bumps, impacts, or even other systems contributing to the driving experience. Very quickly, you're no longer managing a handful of effects. You're designing an entire tactile system by hand. You're deciding which frequencies belong to each effect, which hardware should reproduce them, and how everything should be balanced into a cohesive driving experience. This approach can produce excellent tactile. Many people have built impressive systems this way. As those systems become more sophisticated, however, they also demand more knowledge and more user involvement. Profiles may need to be tuned for different games. Different vehicles may benefit from different adjustments. As more effects are added, maintaining a balanced and cohesive experience becomes increasingly dependent on the user. None of this means traditional tactile is the wrong approach. These are simply the challenges that naturally arise from building a system of independent triggered effects. Each effect responds only to the telemetry available at that instance. It has no awareness of how the vehicle arrived there, how energy was built or dissipated, or how much one mechanical system influences another. Mass Effects takes a different approach. Instead of reacting to isolated events, it continuously models the mechanical state of the vehicle. That means every response is based not only on what's happening now, but also on the history that led to this moment. Mass Effect still begins with live telemetry from the simulator. The difference is what happens next. Instead of using each telemetry value to trigger an individual tactile effect, that data becomes one of the inputs to a continuously evolving vehicle simulation. The simulation combines live telemetry, vehicle-specific data, and modeled mechanical behavior to maintain an evolving representation of what the vehicle is doing. To organize that simulation, Mass Effects is divided into specialized subsystems we call MassEffects-a. MassEffects. Each system models a different area of vehicle behavior. The engine system models combustion behavior, mechanical response, load changes, and vehicle character. The suspension and impact system models wheel movement, surface interaction, load transfer, chassis response, force propagation, and secondary mechanical motion. The curb system models strikes, release, texture, and resonance. The gearshift system models drivetrain engagement and torque transfer. As the simulation evolves, each system continuously generates its own complex tactile waveform. Those waveforms are then combined and delivered to the appropriate tactile hardware. The result is a cohesive tactile response that behaves like one connected mechanical system rather than a collection of independent effects. So what does this actually mean for you? It means less time trying to build the perfect tactile profile and more time enjoying the drive. You start with a balanced system that feels consistent across supported titles while still capturing the personality of each vehicle. Instead of spending hours trying to tune frequencies and individual effects, you simply adjust the overall intensity to match your hardware and your personal preference. As Mass Effects grows, new simulation systems become part of that same foundation, so the experience keeps improving without becoming more complicated. Less tuning, more driving. For many users, building a traditional tactile system means making every one of these decisions yourself. Which frequencies should each effect use? Which tactile unit works best for each effect? How should everything be balanced? Will this profile work with this vehicle? How much time will it take to get everything dialed in? Every additional effect introduces another design decision. As the system grows, so does the effort required to configure, balance, and maintain it. Mass Effects takes a different approach. You simply tell us what hardware you're using. The mapping assistant automatically generates a balanced system that's aware of your hardware, frequency capabilities, and the simulation architecture. From there, the mixer lets you shape the overall feel to match your personal preference. The result is a consistent tactile across supported titles and thousands of vehicles, with fewer decisions and more time driving. Hopefully this has helped explain not only how Mass Effects works, but why it takes a different approach. By modeling the vehicle instead of individual effects, the focus shifts away from engineering the tactile system and back to enjoying the drive. Less tuning, more driving. Thanks for watching.